Okay, so last time we were talking about sort of the policy interest in trying to reduce obesity through regulations that involve restaurants. But despite all this policy interest, the actual direction of causality here between restaurants and obesity is not as clear as you might think. So the problem is basically that when you look at people who eat at restaurants and see that they eat more when they're at restaurants, you don't really know if that's because the restaurants are causing them to eat more or if it's because people who have higher caloric demand go to restaurants to begin with. So when I say higher caloric demand, I mean in like the economic sense of they want to ingest more calories, not necessarily that they burn more calories. So they're burning extra calories, and obviously there wouldn't be an obesity problem. So that's one problem. Another problem is actually you kind of have to think about what happens throughout the entire day, and we'll see this with some of the results later on today. But even if you eat more calories at one point during the day, if you become satiated and then eat less at another point, then the net effect of eating those additional calories during the beginning of the day is going to be less than you might expect, right? Because what matters at the end of the day is your total caloric intake for that day. And so if there's some of this offsetting behavior going on, then there won't be a huge effect on obesity from eating those extra calories. So the real questions here are essentially what's the counterfactual? Would the customer eat less if he or she were eating at home than if he or she were eating at the restaurant? In order to answer those questions, what we really need is some source of variation in restaurant prices that's uncorrelated with demand. So like the ideal experiment here from trying to measure the effect of the policy would be to sort of go around and like randomly assign different prices to different restaurants in different towns. So it's like some towns will basically have high price restaurants, which of course is going to discourage eating at those restaurants, and other towns might have low price restaurants, which would of course encourage eating at those restaurants. And then you can compare whether or not obesity in the long run like increases in the towns where restaurant food is cheap versus the towns where restaurant food is expensive. So that's kind of like ideally what we'd like to do, but obviously you couldn't actually design a study like that. There's no way that you'd be able to fund it at least because it would require like massive subsidies of restaurants in various towns. So what we do instead is that we look at interstate highways in rural areas and use these as a shock to restaurant supply that's uncorrelated with local demand. So this is sort of a case of like sometimes people wonder, well, where do you come up with research designs? How do you come up with a research idea? And this is basically a case where I was just on vacation and I sort of came up with a research idea, which is to say like, I think I was driving up to Tahoe with my friend or something, and you pass through some of the smaller cities as you get into the, not even cities, like smaller towns as you get into the Sierra foothills, and yet they have like 8 fast food restaurants each. And it's clear that there's no way there would be that concentration of fast food restaurants there if it weren't for the highway. So the restaurants are there to basically serve the highway travelers who are coming through, but that has this kind of unintended consequence that for people who happen to live in those towns, then there's a lot of fast food and it's readily accessible. Whereas if you thought about sort of people living in a similar town that was maybe 10 miles away from the interstate highway, it would be much more difficult for them to access fast food. So what we do in the study is we basically compare two groups of towns. We look at towns that are 0 to 5 miles from the highway, so those are what we'll call like adjacent or near highway towns. And then we look at towns that are about 5 to 10 miles from the highway. So the reason that we're sort of concentrating on this like 10-mile band around the highway is that we want to make the two sets of towns as comparable as possible, except insofar as one group of towns has better restaurant access than the other. So in theory, you could say like, well, why don't you look at towns that are right on the highway and compare those to towns that are like 100 miles off the highway in the middle of nowhere or something. Obviously, those towns that are 100 miles off won't have good restaurant access, but you would also think that maybe people who live in like really, really isolated towns might be different than people who live in towns that are close to the highway, even if they're both sort of small towns in a population sense. So the hope then is that these two different groups of towns are going to display differentials in restaurant access that are uncorrelated with either local demand for restaurants or with sort of general health practices, other things that might affect obesity levels. And just to give you a sense of like what these two groups of towns look like on sort of a larger map, what we did is we made a map of some states in the Midwest. I forget, I think it's like Iowa maybe is like the state that's in the center there. So it's one of the states in our samples. But what we plotted here are the interstate highways that go through these states. And then there's these red dots and the blue triangles. And so basically what the red dots are showing you are the zip codes that lie within 5 miles of the highway. And then the blue triangles are showing you the zip codes that lie 5 to 10 miles away from the highway. So like what you can draw from this graph, or from this map rather, is that all of the towns that we're looking at basically sort of share in or benefit from the lower transportation costs that the highways are going to bring, certainly relative to a town that maybe is like located over here in the middle of nowhere. But some of them are going to basically have better restaurant access and some of them will have worse restaurant access. Now, I mean, I don't know about you, but if I were looking at this graph or this map, my sort of inclination would be to say, well, yeah, I can see that those two groups of towns are like pretty close to each other, so they'll probably be pretty similar. But my concern is that maybe there isn't actually much of a differential in restaurant access between the two groups, right? Because even though the red ones are right on the highway, the blue ones don't look like they're all that far away from the highway in some sort of global sense. And so you might think that even in the blue triangle towns or zip codes, that people would still have pretty easy access to restaurants. So one thing that we did, which I'll talk about a little bit later, is we actually went and conducted a survey of sort of an equivalent, similar sample of towns in the Central Valley here in California to figure out whether or not people were actually eating more fast food when they live right near the highway than when they live further away. It turns out they are. And we employed several Berkeley undergrads to do that during like 105-degree summer when there were forest fires or something. So we paid them good wages, but it wasn't an easy job. So for highway travelers, so even though these two groups of towns are pretty close to each other, for highway travelers, these adjacent towns are going to be much more convenient in terms of food options than non-adjacent towns. Right? So if you're driving on the highway, even if it's just a 7-mile detour, nobody wants to take drive 7 miles off the highway, go to McDonald's, and drive 7 miles, get back on the highway. If you can just drive 20 miles further down the highway and get off in an exit where there's McDonald's right there. So in economic terms, what we'd say essentially is that the highway travelers' demand for these restaurants is going to be highly elastic with respect to distance from the highway. And because of that, then these towns that are right on the highway should experience a positive shock to restaurant supply relative to the non-adjacent towns. And so we got data on basically location of all of these restaurants in a whole bunch of states and calculated what percentage of towns or zip codes that were right on the highway had fast food restaurants and what percentage that were further away from the highway did. And so this difference here is statistically significant. So basically what we found is about 70% of towns that are right on the highway have fast food restaurants, and 50% of towns that are about 5 to 10 miles from the highway have fast food restaurants. So it's basically a 20 percentage point differential.
And it's just in the state of California?
No, so this is actually in so let me see, I don't think I have the list of states here now, but this was basically mostly in sort of like Midwestern states, so like Iowa and Kansas, and then some, there were, I think, like South Dakota, maybe some sort of northeastern states too, like Vermont. But the restriction here, so the reason that we don't have states like California or New York in it is that, first of all, we need states that have like large rural areas because like this type of design wouldn't work in a Bay Area because there's fast food restaurants everywhere, whether or not you're on a highway, right? The other issue, though, that's sort of a little bit that you wouldn't necessarily think of immediately is it turns out that the data source that we use, so what we're going to do is we get people's body mass index, basically the reported weight and height from this survey that the CDC does. It turns out that the CDC collects its samples basically on a state-by-state basis. So the sample size for each state is actually pretty similar, even though a state like California has 50 times the population of a state like South Dakota. So what that then in turn means is that essentially the sampling rate of people is much, much higher in these smaller population states. So we actually get sort of much better sample sizes when we look at the smaller population states, just because a much higher proportion of the people there are actually getting sampled by the survey, if that makes sense.
One more question.
Yeah.
What's in terms of statistics class, you might learn that sample size doesn't as long as it's a simple random sample, like the size doesn't really matter.
Well, so in terms of like the unbiasedness of the result, that's true. But in terms of getting like the standard error small enough so you can get a pretty tight confidence interval, then you always want like a larger sample. So yeah.
Oh, yeah, I was going to ask, so is this, are they just counted if they have like one fast food restaurant? Or is it
Yeah, this is sort of like, do you have any fast food restaurants? It's not looking at the number. So if you look at the number, also, then actually I think the differential here becomes sort of even larger in a relative sense. The reason, though, that we didn't look at the number, we didn't like our results don't really sort of focus on the number, is that we're not sure. So like at the end of the day, we kind of want to talk about like the economic cost of accessing a restaurant. And if you're talking about do you have any restaurant at all in your zip code versus do you not, then you can sort of make this like travel time and travel cost argument about the cost of accessing the nearest restaurant. But once you start talking about like do you have one fast food restaurant versus three, it's not so clear what the lower cost of having three restaurants is, right? Because it's like travel time might be pretty similar if they're all clustered near each other. It's going to be more about like variety and maybe competition that brings down prices. But we don't really have a good handle on sort of how consumers are necessarily going to value those things. The other thing that we wanted to examine is kind of like, is the difference in distance to access the nearest restaurant economically meaningful? And so to get a sense of that, what we plotted here are basically, so there's two distributions here. I guess first focus on just the blue line, which is adjacent to highways. So what that's plotting is basically the distribution or the density of distance to the nearest restaurant for all of the zip codes that are located on highways. So what you can see basically is that if you live in a zip code that's on a highway, then this blue line has a lot of like mass, a lot of area under the curve between say 0 to 5 miles or maybe 0 to 7 miles. So what that's telling you is essentially that most people who live in those zip codes only have to drive 5 miles or 7 miles or less in order to access their nearest restaurant. And then there's like maybe a small portion who have to drive more than 15 miles, but it's really the density that's falling off towards 0. On the other hand, if you look at the red line, the red dash line, which is non-adjacent highway, so that's plotting the same thing, but now it's plotting it for zip codes that are located 5 to 10 miles off the highway. And you can see that there's still like a pretty good amount of mass between 0 to 5, so that's saying there are a fair number of people who, even off the highway, only have to drive 5 miles or less to get to the nearest restaurant. But there's much more mass in this sort of like 5 to 15 mile range for the red line. So that's basically what that's telling you is that if you live off the highway, then statistically speaking, you're much more likely to have to drive at least 5 to 15 miles in order to access your nearest restaurant. So then the outcome that we plot is, of course, the body mass index, average body mass index. Actually, it's not really average. This is the entire distribution of BMIs for people who live in each of the two groups of towns. So the takeaway point here is that both of those distributions are almost exactly the same. So the blue line is giving you the distribution of BMIs for people who live in towns or zip codes that are right on the highway. And you can see it's like sort of centered around, I don't know, I think it's probably 25 or so is the average BMI. And it ranges all the way from like a little bit below 20 to above 40. So like a healthy BMI would probably be in the low 20s. That's sort of what the rule of thumb would be in. When you get above 25, you're considered overweight, and when you get above 30, you're considered obese. So that's the distribution of BMIs for people who live right on the highway and have better access to restaurants. And then the red dash line plots the same distribution, but now it's distribution of BMIs for people who live further away from the highway and don't have as good access to restaurants. So if you thought that restaurants were going to have a major or a substantial effect on body mass index, then what you would expect is presumably that the red line would kind of be shifted to the left of the blue line, because living off the highway means that you can't eat at restaurants as often, and if they're going to make you obese, then that means you shouldn't be as obese as people who live on the highway. But in fact, you can see that these two distributions basically just like track each other almost exactly. So this is highly suggestive that restaurants don't seem to be a major determinant of BMI. That being said, you can think of at least I think, a couple alternative explanations for why there isn't a difference in the BMI distributions between those two groups of towns. And the two that I think are sort of most plausible or most important are one, that highway proximity might not increase restaurant consumption. So even though it's harder to access restaurants when you live off a highway, maybe people are just willing to drive like arbitrarily far in order to get to McDonald's. We sort of heard that explanation given a lot of times when we presented this paper at various places, and it kind of comes down to an argument that rural people don't value their time, which is not an argument that we were willing to make, but it's always somebody in the audience was always willing to make that. So if the difference in access to restaurants isn't actually causing any difference in consumption, the like rate of eating at fast food restaurants, then of course you wouldn't see any difference in BMI distributions between the two groups of towns, even if restaurants had a causal effect on obesity. And then the second possibility is that maybe there is some causal effect of restaurants and obesity, but then there's some sort of offsetting selection bias, so that essentially like the people who live off the freeway are eating less frequently at restaurants. They aren't as obese, but there's something different about those people. There's like some omitted variables about those people that essentially make them more obese, and so those two factors kind of offset each other, and that's why we're not finding any difference in the BMI distributions between the two sets of towns. So the first, I think, and probably the most serious concern is this idea that restaurant proximity might not actually affect consumption. So I said it seems like being near the highway increases the probability of having a restaurant in your town by about almost 20 percentage points. But in order to really get some handle on this, what we did is we conducted a large-scale survey of fast food customers in rural Northern California to verify that indeed highway proximity does affect consumption. So what we did is we surveyed fast food customers along this section or in the area of Interstate 5 north of Sacramento. So if like you had Sacramento on the map, it would be down here. And then as you went north up there, the next major town you would hit is Redding. Not that you consider that to be very large, but you might have heard of it at least. And the reason we went north, like my initial instinct was like, oh, why don't we just go over sort of like Altamont Pass, out to I-5 or Highway 99 heading down to Los Angeles. But it turns out that like the area between Sacramento and Bakersfield, even though coming from the Bay Area we would think of it as being kind of like very rural and sparsely populated, it's actually pretty densely populated compared to like the middle of Nebraska or something like that. So it's hard to find sort of small towns that are pretty isolated and wouldn't have easy fast food access if you're limiting yourself to looking between Sacramento and Bakersfield. But if you go further north, then it becomes easier to find these towns. So basically in this area, so in this cut out of Google Maps that you see right there, the circled areas, those red circled areas account for all of the fast food restaurants in this entire region there. So you basically see that all the fast food restaurants are on I-5, except for there's a few in this town of Colusa, which is like the county seat of whichever county it's in. So what we did then, so we're looking at this 80-mile long corridor. I think it's about 40 miles wide or something. So it accounts for like 3,000 square miles, just a second, which if you have any, so that turns out to be about like, I think it's like 2/3 or 3/4 of the size of like the state of Connecticut. So it's actually a pretty large area. Contains only 65,000 residents. So that's giving you a sense of, this is like a much larger area than the Bay Area. The Bay Area contains like 6 million people or something like that. This contains 1/100th as many of those.
Do you know the share of the customers who are just like one-time customers and sort of often customers? I don't know that.
Like repeat customers? You mean like repeat customers versus? So we don't.
My personal experience, I used to have a job and I used to go up and down Highway 5. And sometimes I used to stop in these types of restaurants. Many of the customers were not local.
Right.
But I don't know if this is something that might be concerned in this state or not.
So that's an interesting question. I mean, we're not collecting data on sort of a given individual and repeatedly surveying them, so we can't tell how many times, like if I see you showing up at the restaurant, I can't tell if you've ever shown up before because I'm not really following you over time. But we did so what we did is we essentially, I guess I just described the survey actually, and maybe that'll help answer your question. So what the research assistants did is they approached consumers in all 6 of these towns here that had fast food restaurants. And it's basically like everybody, so you'd stand either near the door or actually in the drive-thru, and everybody who came through, they would just ask like, what is your zip code? Because the idea here is we want to figure out, the nice thing is we have like the universe of fast food restaurants in this area, right? So if we know the zip codes of all the people who show up at these fast food restaurants, then we can actually reconstruct using census data. Like we know the populations of each of the zip codes from the census. We can see how often people from each zip code are showing up at these restaurants, and then reconstruct what the actual like fast food visit rate is for each zip code in this area, which is the goal of the study. And so basically we would ask them what their zip code is. And so we couldn't identify if they were repeat customers. We could certainly identify if they were basically coming from somewhere nearby versus if they were like these through travelers on Interstate 5. And your intuition is correct in that in the restaurants that are along I-5, so in like these towns there, I think more than half of the customers are what we're calling like through travelers in the sense they come from outside of the mapped area. And that's actually kind of reassuring in the sense that the original story that I told was that the reason these restaurants are here along I-5 is because they're trying to serve highway travelers, not because they're like trying to cater to specific towns where people have a high demand for eating fast food. But then sort of as a side effect, people in those towns will also have easier access to fast food. So we ended up serving, I guess, like 2,000 customers at 21 fast food restaurants. Now you think like, geez, like you're standing like the drive-through line and just like kind of harassing the customers for their zip code, you probably like get kicked out. There's only I think one restaurant or something where they're asked to leave. The lesson I took from this is that if you're paying people minimum wage, they don't, as long as you're not like doing something that's severely disrupting the business, they have only like limited incentive to actually come and like sort of intervene. So for the most part, our undergrads didn't seem to have any problems with the actual fast food employees harassing them. So what the results demonstrate is that, in fact, highway proximity does greatly increase fast food consumption. So the first thing, which I just mentioned, is that the highway restaurants, the restaurants that are right on the highway, are in fact more likely to serve through travelers than the restaurants in that town that's off the highway. So like 50% of customers in restaurants that are on the highway are coming from essentially outside that map area, whereas only 17% of customers in that one town that was like further off the highway and had fast food restaurants were coming from outside the mapped area. And then the key result that we're interested in is whether or not residents of towns who live on the highway or that are on the highway eat more fast food than residents of towns who are off the highway. And we found that, in fact, they did. So it's basically like a 2-to-1 or like 100% more in the sense that we calculated an average of 128 daily visits per 1,000 residents for adjacent towns. So basically, it's just saying like on average, people had like a 13%. People in those towns that are on the highway have like a 13% chance of going to one of the fast food restaurants on any given day. Whereas for people who live maybe about 10 miles off the highway, they had only about like a 7% chance or so of going to a fast food restaurant on any given day. Then the other thing that we wanted to check or to rule out is that this question of whether or not selection bias affects our results. And so what we did here, so the story about selection bias would essentially be the following. So you can actually think of the placement of the interstate highways within like sort of a small area as being almost random in the sense that the highways were not built to serve these intermediate towns. They were really built to connect large cities. And so whether or not in a small town that's on the highway, like or is near where the highway is, whether or not it had the highway come directly through it versus past 10 miles away, doesn't really have to do much with that town at all. It just has to do with did it happen to be right in between like Sacramento and San Francisco versus did it happen to be like 10 miles off whatever line or whatever the easiest route between those two places was. So in some sense you could think of the placement of the highways being almost random from the perspective of these towns, but the highways were placed there like 50 years ago. So people could so even if the initial placement was random, people can always move in and out of the towns, right? And so you might sort of get people sorting or selecting into living close to the towns or close to the highways, and those people might look different than the people who live further from the highway. And so if that were true, then there might be some sort of unobserved characteristics or like omitted variables about people who live off the highway that make them maybe less inclined to be obese or more inclined to be obese. So what we did is we kind of compared all of the observable characteristics that we had, so things like gender and race and age and employment and education and income and so forth, and we tested whether or not people who lived on the highway, right on the highway, looked any sort of different than people who lived off the highway. And they don't based on any of our observable characteristics, but I think the best way to sort of show this is then to combine these characteristics into what I'll call the predicted BMI index. So the idea here is that you could actually run a regression of BMI on all of these demographic characteristics, and then you could get predicted BMI values for each person, right? And essentially what that's doing is it's like creating some like average, it's literally creating like a linear combination of all the different demographic characteristics, but the weight that each characteristic is going to receive is going to be sort of proportionate to its predictive power for BMI. So like characteristics that are very highly correlated with BMI or with obesity are going to receive a high weight when we're constructing this index, and characteristics that aren't very strongly correlated with BMI are going to receive very low weight. So then we created this index, and you can think of this as almost being like a BMI risk index, and then we applied the distribution of this index for people in the two groups of towns. And again, here you can see that the distribution of the index, like for the on-highway towns versus off-highway towns, was almost identical. You can barely sort of even differentiate those two different distributions from each other at all. So it really doesn't look like there was any sort of sorting that would have created selection bias in the experiment. Sure? Yes. Yeah, no, there was some extra slides that I thought were a little bit superfluous and would not add to understanding, but rather probably detract from it. So I deleted those. Do you want me to upload like new versions? Sure. Okay. So after we finished that part of the study, we were kind of curious because your intuition is that fast food definitely is not healthy, and I think nobody questions that if you do eat fast food on a frequent basis, you will gain weight. And we showed that there was a substantial difference in sort of frequency of fast food consumption across the two groups of towns. So we were a little bit surprised that we couldn't detect any effect at all on obesity. So there's really two hypotheses here that are kind of distinct. They could explain why we don't find an effect. So one is simply that people don't actually eat more calories when they eat at a restaurant, which I think introspection suggests that's probably not true in the sense that I think most of us feel like maybe we kind of overeat a little bit when we go to restaurants because you have like a fixed portion size, you feel some pressure to like eat the whole thing, especially because you already paid for it, so it's like the fallacy